Hello everyone, I am Krishna Shinde, student of MIT UE, studying in second year of mechanical engineering. This is our machine and mechanism activity in which I allotted one topic that I will explain today. Before that, I would like to I would like to declare some content are refer and taken from online available sources like video, data, etc. The topic allotted for me is what is the gyroscope and its effects on aeroplane. Let's start with what is the gyroscope. Basically, gyroscope is a device that used to measure and maintain orientation and angular momentum. Gyroscope contains a spinning disc or vibrating sensors that detect angular motion, turning left, right, up or down. It does not relate to gravitational force. Here you can see this is the diagram of gyroscope. This is the gyroscope frame, this is the gimbal, and this is the spinning axis. Now move on next topic. Basically gyroscope has a three axis, that is x-axis, y-axis and z-axis. X-axis is called the spinning axis, y-axis is called the precision axis or is rotation axis, and z-axis is called the tilting axis. Then move on next topic, that is a right hand thumb rule gyroscope. The right hand thumb rule for a gyroscope dictates that if you curl your right hand's fingers in the direction of the gyroscope rotation, your thumb will point in the direction of the angular momentum and angular vector. Here you can see if you curl your right hand finger in anti-clockwise direction, then your right hand thumb represent the direction of the torque. Same if you curl your right hand finger in an anti-clockwise direction, then the finger rep- then the thumbs of your right hand represent the direction of the torque. Here you can see the formula for torque. T is equal to r f sin theta. T represent torque, r represent radius from axis of the spin axis, and f is force applied on the disc, and sin theta is the angle of rotation. Next, use of gyroscope. In a smartphones, basically it used for a screen rotation and motion sensing in a games. In a drones, it used to stay balanced in the air. In a cars, it is used for a stability control, and in robots, it is used for to help them move correctly. How does the gyroscopic effect work in airplanes? Aeroplanes, especially propeller-driven aircraft, experience the gyroscopic effect because the spinning propeller or engine part act like a gyroscope. When the pilot changes the direction, the gyroscope inside the plane reacts in a specific way. Here you can see the diagram of the aeroplane in which the gyroscopic effect applied. This is the x-axis or spinning axis, and on this sorry and on that spinning axis the propeller are fixed. Here z-axis also called a pitching axis, and this is the y-axis, it is called rotation axis or precision axis. The airplane always take left and sorry just if aeroplane take right or left turn, then it takes about its y-axis or precision axis. This axis is this axis is always perpendicular to the earth, and this propeller and engines behave in the airplanes like a gyroscope. And this is the front of the airplane, also called the nose, and this backward part is called the nose of the airplane. Then move on the next topic, that is effect on airplane movements. Pitching means nose up or down. If a pilot pulls the nose up, the force acts 90 degrees ahead in the rotation, causing a slight turn to the right or left, depending on a propeller rotation. If the nose moves down, the same gyroscopic reaction happens in the opposite direction. Yawing means aeroplane takes turn in a left or right. When the plane turns left or right, the gyroscopic force can cause the nose to rise or dip slightly. This is important during the takeoff and landing when the plane changes direction quickly. Then next is why is the gyroscopic effect important in airplanes? The gyroscopic effect helps airplanes stay stable and controlled during the flight. Spinning parts like engine and propellers create forces that resist sudden changes in the direction, making maneuvers smoother. This stability is crucial for a safe takeoffs, landings, and in-flight adjustments. Pilot must understand and manage these effects for a precise control, especially in challenging conditions. In an airplane, the gyroscope, in a plane, the engine and propellers behave like a gyroscope, and this is helps to aeroplane stay stable into the flight during a flight and whenever in the flying in air. This is the effect of the gyroscope applied on the airplane. Here you can see if the propeller is spinning in anti-clockwise direction, then the active couple are produced in this direction. And for for balancing this active couple, the reactive couple are produced in the opposite direction of the active vector. You know the Newton's third law. Every action has equal and opposite reaction. This gyroscopic effect also follow this Newton's third law. When the propeller move anti-clockwise, then the aeroplane nose goes up and the tail goes down. So tail goes down. Same when when the sorry, same when the propeller move anti-clockwise, then the anti-clockwise and take turn in a right direction. Then the active couple are pulls in this direction and reactive for balancing this active couple. The reactive couple are produced in the opposite direction of the active couple. Because of that, the aeroplane's nose goes down and the tail goes up. Thank you for listening.